Hello and welcome to my Pre-Algebra review series. This video covers Chapter 8, Section 1, entitled Relations and Functions. By the end of this video, you should have a better understanding of what relations and functions are and how they are similar and how they're different. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's do some math. So I'd like to start this lesson, this review, if you will, with a few definitions. First of all, let's define a relation. For example, you can write data in a table as a relation, a set of ordered pairs. The first coordinate of each ordered pair is the number of students in a homeroom class. The second coordinate is the number of cans the students collected in each homeroom. So we have a relationship there, which is the number of students in a homeroom class and them each collecting cans and coming up with a quantity of cans based on the number of students. And then you can have a table of multiple homerooms doing that same thing. And so you get now a list of data. Homeroom A, B, C, D, E collected X, Y, Z, whatever numbers of cans. The domain in a relation, the inputs and outputs, or the X and Y values, form ordered pairs. Each input X value can have more than one output value. The X value is called the domain of the relation. The range in an ordered pair, the second term, the Y value, is called the range of the relation. Then a function. Some relations are functions. In a function, each member of the domain is paired with exactly one member of the range. And then there's a thing called a vertical line test. If a relation is a function, then any vertical line passes through at most one point on the graph. If the vertical line passes through two or more points, the relation is not a function. And this is called the vertical line test. That's how you can determine whether something is a function or a relation. To help us understand the difference between a relation and a function, off into the future when the question comes up again and you have to say, what? Well, what is the difference? I can't remember. I have a little story for you here. Maybe it's kind of an absurd little story, or weird anyways, but maybe the thought of this will pop back into your mind. You'll remember that, oh, I remember that story. That's how I know the difference between a function and a relation. So here's the story. Today we are going to check into the world of relations and functions. Two buddies in the land of numbers. Imagine you're throwing a party and you've got a bunch of friends coming to the party. Now think of each of your friends at the party as a number. First up, let's think about a relation. A relation is like saying to the friends at your party, hey, everyone meet everybody. In a relation, the numbers get to know each other and they can chat and hang out. But here's the thing, not everybody has to talk to everybody. Some might be chatting with just one person and the others might be mingling and chatting with a few more. Okay, so what about a function, you ask? With functions, it's like a much more organized at your party. Each person or number gets a specific buddy. No one's left out, and no one's going to double dip. Each input, that's like a party guest, gets paired with just one output, another party guest, like a dance partner at a party. So, in a nutshell, relations are like a big friendly gathering where everybody interacts in their own way. Functions are like organized pairs where each input has its own special output partner. Think of it as the difference between a big, lively party and a carefully arranged dance party. I hope that helps. So in this slide, we're going to identify relations and functions. We have 3 problems with 4 sets of ordered pairs. And what we want to determine is, looking at these numbers, is it a function or a relation? Okay, so the first set of pairs are, an A, we have 0, 1, 1, 2, 1, 3, and 2, 4. That's our ordered pairs. So we look at it. We go from 0 right here, from 0 to 1. That's a 1-to-1 relationship. That's like the dance partners, right? Only 1-to-1. Now here, input number 1, the domain 1 has 2 outputs. Well, that's more like they get to talk to as many partners as they want, right? They can have more than one. And according for it to be a function, it can only have one. It could have a 2 or the 3, but it can't have both. And 2, here's 2 is going to 4. Well, so it's like a mixed bag. Here we have some specific organizations and a kind of a random kind of a set of friends, if you will. So no, 2 range values for one domain. 2 range values for one domain. This is not a function. How about B? 0, 1, 1, 2, 2, 2, and 3, 4. Well, in this case, we have the domain here of 0 has 1 as its match. 1 has 2 as its match. 2 has 2 as its match, and 3 has 4 as its match. Well, the definition of a function says that each domain can have only one. In a relation, the domain can have more than one. So this is a relation over here, 1, 2, and 3. This is a relation. The one domain has 2 outputs, 2 range values. Here, 1 has a 2 and 2 has a 2. So is that legal? Is that a function? Yes, it's a function, because each domain only has one range value. That range value might be pointed to from more than one domain value, but it's still each domain value only has one given range value. So yes, this is a function. 1 range per domain. Now do the last 2. 0, 1, 1, 3, 2, 2, and 3, 4. So here we have domain 0 goes to range 1. That looks like a function so far. 3 goes to 4. That's 1-to-1 relationship. Sounds like a function. 1 goes to 3, and 2 goes to 2. The fact that they're crisscrossing here is irrelevant. Yes, 1 range for each domain. So the first one is a range, is a relation, and the next 2 are functions. Okay, so now in Check Your Understanding, we're going to do this on our own without the help of the little tables and arrows and stuff. So is each relation a function? So let's take a look at A. So -2 and 3. Let's put it this way. You have a -2, a 2, and a 2. And the -2 goes to a 3. There's nothing else because there's only one -2. We have two domain values. The domain here, these 2 are the same. Do they go to different places? This 2 value goes to the range value of 2. This 2 goes to a range value of -2. So no, there are 2 range values for the domain. So this is not a function. This is a relation. This is a relation. How about B? -5 goes to -4. 0 goes to -4. 5 goes to -4. So every one of these domain values all point to the same output. Is that legal? Yes, it is. As a function. Yes, there's only one range for each domain. So this is definitely a function. Example 2, real-world problem. Is the time needed to cook a turkey a function of the weight of the turkey? Yes or no, and explain. Well, let's think about it. is the time it takes for a turkey to cook, which is the range value, is determined by the weight of the turkey, is the domain value. So I think it's going to say this is a relation, and it is absolutely a relation. This is a relation, is a function too. So why is it a function? Because no matter what the weight is, the turkey's weight, you're going to get a specific time to cook it. So if it's a 1 pound, it could be 2 minutes. If it's 2 pounds, it could be 2 minutes. But it's not 1 pound equals 1 minute, and then you go down and have another 1 pound equals 2 minutes. So this relation is definitely a function. So for example 2, we have a couple check your understanding problems here. So let's answer these questions. For the United States Postal Service, is the package weight a function of the postage paid to mail the package? And explain. Well, is the package weight a function of the postage? So does that mean that if I give you the postage amount is, say, $3, does that define the exact weight of the package that you have to mail or that you can mail? Well, the answer is going to be no to that, because what's going to happen? No, because the specific postage amount, the domain, can mail packages of different weights. So you can have $1 for, say, a range of packages from 1 pound to 1.5 pounds or 2 pounds. It could all be $1 price range. For B, the cost of postage a function of the package weight. So, and they want us to explain there. Is the cost of the postage a function? A cost of the pack is the cost of I can't speak. Is the cost of postage a function of package weight? And the answer to that is yes. If you think about it, for each package weight, the domain value, there is one postage cost to the zip code, for instance, which is the range value. So if I have a 5 pound package, they're going to charge me possibly $3, and if I have a 5 1/4, up to say 6 pounds, it might be the exact same postage. But whatever it is, the weight could be completely. Every ounce could have a different price. Every 1/10 of an ounce could have a different price, but they'll all be delineated so that you can see, oh, the package weighs so much, and it's going to cost me exactly this amount. You've probably seen this when you go into the post office. Okay, objective 2, graphing relations and functions. Graphing a relation on a coordinate plane gives you a visual way to tell whether a relation is a function or not. If the relation is a function, then any vertical line passes through at most one point on the graph. If you find a vertical line that passes through 2 points on the graph, then the relation is not a function. And doing this act of taking this line, this vertical line, we call it the vertical line test. So, and I could draw one. Let's draw one out so we can see what it looks like. So if I have a graph, okay, we have a graph like this, and we have, say the graph does this. Okay, it's kind of oddballish, the shape of it, but it's good enough for our example. No matter what your x value is on this graph, here's your y values, you have this x value over here it can have more than one y output, but this only goes to 1. This goes to negative something or positive y. And this one here also goes to a y. So it's definitely a function. Okay? Relation, a good way to look at a relation would be, let's draw it this way. Okay? Here's our function. So here, going to this one, if I draw a vertical line, no matter where I draw the vertical line, as crooked as that line is, I draw vertical lines through here, it can only hit one spot. Hits it there, hits it here, hits it here, hits it here. On this test here, if I draw a vertical line right through here, I have one x value and two y values. And all along this, I get the same thing. No matter where I draw the line, I get one x value and 2. Except for maybe right here at the tangent to that guy, it might only be 1, but that's not relevant. It's still a relationship. So in example 3, using the vertical line test, they have a graph. Graph the following table. So we have a domain of -4, 2, 2, 4, and 5, and a range of -3, 0, 3, 3, and -4. So we have to graph these dots out, and as we look at them, we have a dot over here, which is let's see, 4, -3. Here, -4, -3 is this one. And then 2, 0 is 2, 0. Here's 0. Here's 2, 0. And 2, 3 is this one here. And here's 4, 3. So here we got a 4, 4, 3 right here. And then finally we have 5, 4. So we go out 5 and down 4. 5 minus 4. Well, here's our vertical line, and guess what? If I slid this line over, it would go through both of those points. So this is what? A relation or a function? So it says here, as you can see, the vertical arrow would cover both data points. This is a relation. So example 3, check your understanding. Same thing we just did. So that what they do is they want you to plot all the points. So we plot -6, -5 over here, -3, -2, which is this one here. Here's the -6, -5, the -3, -2, the 0, 2. Here's the 0, -2 right there. 1 and 0. Here's 1 and 0 right there. And we have 4 and 3. So way out here at 4, we go up to 3. Here's our 4, 3. And our 5, 7. 5, 7. Way over here, we went out 5 and up 7. Okay, do any of these points coincide to the point where you have one domain having 2 ranges? The answer is no. So this is a function. How about this one here? The next one down. So we have a -7, 4. Here's 4 going up. Here's the 0 line. So -7, 4, -2, 6, -2, 6. And we have -1, 1, -1, 1. And here we have another -1, 3, -1, 3. Guess what? 0, 5. Here's a 0 on the x and a 5 on the y. And the last one is 1 and 5. Here's 1 and 5. So these are on the same line this way, but what we're concerned about is a vertical line this way. And guess what? I probably can't draw this, but a vertical line goes through these points here. So this is a relation. It is not a function. It's a relation. Okay, for our last slide, exercises. Is each relation or a function? Let's explain. Well, let's see if we can figure this out as easy as possible here. So what are the rules here? Here's our domain values. The x are the domain values. And if we look down the domains, in this case, we have a -5, a -2, a 3, and a 6. None of these repeat. Since none of these repeat, it does not matter what the range value is relative to those numbers. This has to be a function. Okay? Number 2. The domain value is 3, 1, -1, 3. So now in this case, we've got a 2 minus a 2 3s. So does this 3 point to the same spot, or does it point to a different range value? This one points to -7. This one points to -7. Oh, well, that's okay, because each domain value only has one range value. So this is a function. It's a little trick played there, I guess, for us to think about. Here, x, the domain value. We have a -7, a -5, -5, and okay, so we get this one and this one is a pair of the same number, and the 5s here are also -5s. So now we got 2 times we're going to look at this. So for the -7s, the -7s go to a 3 and a -3. Oops, not good for a function because minus 7 is doing minus 3 and minus 7 is doing 3. Right off the bat, I can tell you this is a relation. Okay, the minus 5s here go to two different values also. So both of these prove out to be relation and not a function. 4. The domains, we have 6, 1, 0, minus 1. They're all differing. So I don't care what these over here on the range side are. As long as these domain values are all different, you can only have a function. Okay, good. Good job.